Hello, this is Mr. McGovern, and this is the third video in the acceleration series where we're going to look at the equations of motion. So we'll introduce you to the equations and how to use them and finish with an example. So the equations of motion, and this is how they're set out on your formula sheet, looks something like this. There's a bunch of symbols, and there seems to be a lot of equations. So why do we have so many and how do we use them? The first one is one you should already recognize. Velocity is change in position over change in time. That equation is for constant velocity. Okay, so we're looking at acceleration series at the moment. So even though that's in the same line as the rest of the acceleration ones, you need to be able to recognize you only use it in situations where something's going at a constant velocity. So what I'm going to do is I'm going to, for the next one, make sure I blank that out so I don't get confused with it. But you need to be able to see that when you go to do your only calculations and know that that's not an acceleration formula, that is a constant velocity formula. So the symbols for the rest of the equations, A stands for acceleration, D stands for displacement, T is the duration of the travel, the time taken for this travel to occur. The reason I haven't just said T equals time is because I don't want to mix you up by saying, well, it's 12 o'clock or it's 7 o'clock. That's also time. We're talking about the time taken for an object to move a certain distance, and the other word we use for that is duration. VI is initial velocity. So V is velocity, and because we're looking at multiple velocities, what the velocity that it starts at and the velocity that it finishes at, we need a separate label. So the little I there stands for initial, and it's a subscript. It's the I is written down slightly below the V. We're going to see quite a few subscripts throughout physics the next couple of years. Subscripts are labels. So I've got velocity and I've labeled it and said I just want to look at the initial velocity. So the other one with a subscript is final velocity. So it's V with a little f down the bottom, a little subscript, which means the final velocity. Why do we have so many equations? We have so many equations because often what you'll do is you'll be given enough information that we only need to use one of these equations. Let me give you an example. Let's say I've circled the equation here. You'll notice that that equation has an A in it for acceleration, it has a D in it for displacement, it has a T in it for time or duration, it has a VI of initial velocity, but it does not have a VF. Okay, so that'll calculate distance, but you don't need every piece of information. You can do it without the final velocity. Let's pick another one. If we pick this one here, you'll see that this has an A in it for acceleration, D for displacement. It does not have a time in it. It has an initial velocity and a final velocity. So you can calculate some things here. This equation is useful if you do not have the time. So you'll see that all of these equations are missing one of the values. The first one was missing final velocity. The one I've circled is missing time. I'll look at another one. That one has acceleration. It does not have displacement. It has duration or time. It has initial velocity and final velocity. So you see all of these equations, you will pick one based on what information you've been given or need to calculate. It's often easy to look for them and say, look, what is the information I'm missing? And therefore I'll pick to use that equation. So there's 5 equations there. You only ever need to use one of them at a time. And you'll pick the appropriate one based on what information you've been given. So how do I use them? The first thing you do, what we've been doing all along, is draw a motion map, and this will help you understand the situation's constant velocity of acceleration to know if you're using the constant velocity formula or one of these acceleration equations. The motion map also helps you decide if things are positive or negative. Once we've done the motion map, we can identify what things we have, what variables we have, for example, acceleration or initial velocity, and then also identify what we want to calculate. Once we've done that, we can pick the equation that's most appropriate and finally solve it. So let's do an example. This is the car accelerating from 0 to 20 meters per second over 4 seconds. Find the distance that it travels. Draw a motion map. So this is the same situation in video 2 where we looked at the graphs. So same motion map here. The motion map tells us that the velocity is increasing, so I know I'm going to be using the acceleration formulas, not a constant velocity formula. It also tells me my velocities are positive and my accelerations are positive. So it's going to be very helpful for the calculation. So I've helped understand that this situation is constant velocity acceleration. I've identified positive and negative values. Now we identify what variables we have. So I go back to my question. I have a 0 there. That's my initial velocity. So I started off at 0 meters a second. That 20 is my final velocity, and it's positive 20 meters a second. I know that from my motion map. 4 seconds is the duration or the time that we're traveling for. And now we can identify what we want to calculate. So find the distance it travels, d equals. And I usually, even though I don't know what that value is, I want to find it out, I will separately write it down myself with a question mark there. So now I'm trying to find a formula that has those 4 variables in it, VI, VF, T, and D. And the one that I'm going to use is this one here. See, any of the others have a value I don't have. For example, a lot of them have acceleration, which I don't know that yet. So this is the formula I'm going to use because it has VI, VF, T, and I want to find D. So let's go ahead and use and solve it. So I write the formula out, substitute in, and simplify out, and I get D equals 40 meters. So the car accelerates from 0 to 20 over 4 seconds. It travels 40 meters during that time. Now this is the exact same question we did in our graphs, and we also, and this is the slide from the graphs, got that same answer. We got that 40. So knowing how to do these in 2 separate ways, one with the equation and one with the graphs, especially if you're considering yourself an excellent student, it allows yourself to check your answer by doing it in 2 separate methods and making sure you get the same answer for both methods. So when we go through our examples in the next video or videos, I might do 2 examples. I'm going to go through them using both methods, both the graphs and the equations.